Hey everybody, this is Larry. This is me doing virtual contest, Biweekly Contest 158. Happened about 4 or 5 hours ago. So yeah, just didn't wake up early enough. But here in New York City, for me it's 10:30 a.m. as you can see here. Hit the like button, hit the subscribe button, drop me on Discord. Let me know what you think about this contest, these problems, everything in between. This is a live recording of me trying to solve these problems for the first time. So if you are looking for explanations or at least deeper explanations, definitely check out. Each farm will have his own video. So there you go. Yep, that's all I have. So let's go. Virtual. Am I ready? Yeah, I'm as ready as I'll be. Let me make sure I'm recording. All right, 5, 4, 3, 2, 1. Go 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 go. Do. All right. What is it? It's a little bit awkward. All right. I is JK. Maximize. Okay. 10 to the 5th, so we can do it. This is an awkward one, for sure. Basically, you want something that's like inverse, right? Okay, maybe. Still an awkward one though. I mean, I think what you want is like the inverse, but maybe it's a little bit tricky to do that. Something like for the Leetcode silly color again. No choice about it, but I don't know. Something like that, maybe. Yeah, I see. I think that's fine then, right? And then just take the max out. Okay, yeah, okay. I'm overthinking it. I think that's why. In fact, I don't even need this anymore. I just go, right. And then now this is just gonna be if s dot list of s or length of s is greater than equal to 3, then s dot values, we want to sort them. I get n largest actually. Something like that, otherwise return -1. Int not iterable. What? Isn't it? Oh. No, that seems right. Oh. What? I forget how to use cute and largest. Did I have the syntax incorrect? Probably. N iterable. Oh, sorry, it's the other way. Whoops. 14 -1. All right. YOLO submit. Where's the submit button? It's here. Leetcode always finds like a. I don't know how they keep on finding different ways to be like just bad UI in a way. Let me reopen these. Why is the code on the left? I probably have changed it, but it's still like not the. Wait, let me. Isn't there like a? Okay, so I could do that. I could apply default layout. Okay, fine. Alright, Q2. Let's go. Leetcode is so, I don't know. Like they took something that kind of worked and then made it like not good for everybody. Anyway, You're given an integer array price. Price is rise the price of the stock in dollars on the ith day, and an integer k. You're allowed to make at most k. What? Okay. Integer array prices, where prices of I is the price of the stock in dollars on the ith day. Okay. I mean, that's fine. What does k mean though? Oh, you could make k a transaction. Normal. Sell on a later day. Okay. Short sell. Oh, huh. Okay. You must complete. Okay. Return. I mean, I guess this is just standard DP. Right? Is it? Okay, yeah, that's right. I forgot about K. But still standard DP, right? We'll see if this times out just because Leetcode is silly, but yeah, maybe I do something like can buy index for the day and then K left, right? Okay. So then now, if index is equal to n, then we just return 0. Not really doing anything. 1,000 squared is actually a little bit tight on Leetcode's silliness. So if I get it wrong and time limit exceeded or memory exceeded, I blame it on that. Anyway, so okay, so now we buy no buy, right? So buy is we can sell. At index plus 1, we made a transaction. What is a transaction? Is it one transaction to buy and sell, or? Okay, I mean, that's not how a transaction works in things, but okay, fine. Yeah, okay. Can sell plus it's a little bit awkward, I think. I might have to do another state, but can sell minus prices of index. So that's for if you buy. And then the other one is if you can just can in the future. Okay, I think yeah, I get it. Okay. Free will, maybe like a free action, say. So index is equal. Next is equal to n, then we return 0. Otherwise, we can either buy. So we can buy. If we buy, then we do a can sell, right? So can sell index plus 1, k minus 1 minus prices of index. We had that. And sell is going to be can buy back index plus 1, k minus 1 plus prices of index. This is short. Long short, right? And then the other thing is just nothing, right? So then that's 3 of index plus 1k, right? So here, then we just take the min of these 3, right? So yeah, best is you go to, I guess just not doing anything. So let's just say 0, right? So best is to go f min from f max, best right? I have to check that we have transactions left, of course. Okay. And now it's not can buy anymore, it's that when to sell, right? The naming is a little bit bad, but we already shorted when to sell. Complete buy. Okay, that's what I'm curious about. But okay, so when to sell, right? So to sell, then we sell back the prices, but then now we just go back to free, right? That means that we have a free choice, or we don't. So then that's just keep on and buying plus 1 k, right? And of course there's no thing here. So then now we have to just a lot of typing, honestly. I don't think this is that bad, and we'll see, in the sense that it may still let's actually set this to this, right? So we'll see, because because Leetcode sometimes is just really silly about it on running times. But this is not that bad. This shouldn't be that bad. All right, so this is by back. So that means that, okay, we brought it back. Plus prices of index. And then that's it. Right, so then now we go to 30K. 1640. Okay, so that's really wrong. Have to double check. I think we're off by one of the indexes. But also trying to, before I forget, because for whatever reason, that is what we have to do. Okay, I just want to real quick because I might have typo. Okay, so 16. How do I get 16? All right. Days. So I'm better than the result, which means that I'm doing something a little bit nuttier. Cancel. So this is just, yeah, I don't think. I feel like this cannot be that wrong. Short. Oh, I see. It's because we short without because okay, yeah. I don't want to. I don't have time to explain it, but I just say we. I guess you have to sell. So okay, so wait, what's the max? Okay, fine. Oh, still not work. Because we short. Oh no. Oh, I did it wrong. I mean, I guess it's nice to have it here, but it should be on this one because we're shorted. The reason is because when we already shorted, we already have to. We get the money from shorting it without buying it back, and that obviously is that's really a great trade if you could do it. But yeah. All right. Am I fast enough? All right. Let's go. If Leetcode gives me like a memory limit exceeded or time limited, you know, I'll be very unhappy. But okay, that time it looked okay. So, all right. So now we have 2 hard problems. How are we doing on rank? Ooh, not so good. People, I took 8 minutes in Q2. I guess it's just, a lot of it's just typing. It's fine. All right. Q3, maximize subarray GDC score. You may perform at most K operations to choose one element. Double is right. Each element can be double at most once, so that means that you could double K of them. The score of the contiguous subarray is defined as the product of its length and the greatest common divisor of all its elements. The product of its length and the greatest GCD. It has to learn maximum score that would be achieved by a contiguous subarray from the modifier array. What does that mean? Okay, double 0 to 4, and then now GCD is 4. Okay. How do we get a subarray GCD? Okay, n is only 1,500. That's interesting. Maybe we can do n squared type things. What would that look like if n squared? N squared times k is definitely too slow, but n squared. GCD. GCD. Right, 10 to the 9. That's interesting actually. That means there's no CIF or prime or anything weird. That means it is n squared then, right? If there's no way to kind of optimize based on num sub I, then it's n squared. So okay, so you have a subarray. How do you choose very fast what to double? Do you always double the smallest number? I guess so. Because by definition, the smallest number The GCD is at most the smallest number, so I guess so. GCD is the smallest number, and you're going to do it once, so that means that you take the case smallest number and then multiply by 2. But you don't have to explicitly do it though, right? It's just that you take the GCD of those numbers. What is the math? What is the math? You want to do that in a sliding window kind of way. What is the math of that? Or how many numbers do you have to do to change the GCD? I guess that's the question. Right, you only change one. Yeah, so now you have. So you have. So basically, you want the GCD of inside and outside. Inside is easier. No, is it? No. I guess they're both kind of hard. How do you do a rolling GCD with changes? You add in the numbers easy, sure. I guess actually outside is easy. But then how do you remove a number from a GCD calculation? You have something like this, and then now this is gonna be G numbers start. Right. So we don't have anything, then this is going to be the answer, right? But that's not quite. But we have to do this K thing, right? 4, 7, 15. How do I do the K thing? Break down the conversation, but how do you remove a number from a GCD calculation? Okay, so you have two populations, right? You have Okay. But the thing is that we're not doing with two unrelated populations. It's just divided by 2, right? On some parts of it. So the GCD of everything inside is just 2 times what it would have been. Because you're always removing the biggest number, it should. Because you're removing the biggest number, it should not affect the GCD. Is that right? I guess so, maybe. I don't know if that's true, but okay, let's just say. So this is at least something. We could probably remove it, but we have stuff that's okay. Doubled and not, right? So can we even do n square log n? Is that too slow? That's like. I feel slow though. We remove the biggest number. What does that mean? Does removing the biggest number ever change the GCD? Yes, but also no, because again we removed it from the. Okay, fine, right? So so we have something like G is equal to 1, then we break, just because if that's the case, there's no way to get it anyway. But otherwise, we have inside. I don't know if a heap is good enough though. It feels a little bit too slow, but even 1,000 it would feel a little slow, and as you go to 1,000. But we want a max heap. Right, so everything inside the heap is doubled. So maybe we have a GD. Can K is equal to 0? K cannot equal to 0, so okay. I don't know, I want to say. Alright, just start it off here for now. I guess it can go higher though, right? Because you can say, so if within you go from 2 to 3 to 2 to 2, well, GC of 2 to 3, now again, because it goes outside, still is the case. I mean, it's going to be 1 on the inside, but then when the 3 goes outside, it's still going to be 1. That's why, Larry. Stop. Keep on doing this. Okay, fine. Okay, so yeah. Fine. Is it going to... Okay, so... So that's the doubled. We pop out the number. G not double. Yeah, this is so awkward. I don't know. There's like no good sentinel value. That's why like I'm struggling a little bit. Okay. I guess I have to just do it this way, even though it is very awkward. Oh wait, no, this is not true. It's not yet. Okay, so these are the doubles, and then now not double. So then if length of heap is greater than K, then we pop it. My period not working. X is equal to, and then now G is equal to GCD of G and X, right? Only if G is equal to 0, G is equal to X. It's kind of awkward, like I said. That's fine, right? And then now we have GCD of GD times 2 and G. And then we have this thing, right? Best is equal to F max, best times n minus so plus 1. I'm not confident about this at all. But let's give it a spin at least. 8, 14, 15. All right, let's give it YOLO submit. There's so many things wrong with this. It could time out. It could just have a wrong answer. So let's kind of, ooh, huh. So yeah, so a lot of places, a lot of potential wrong answers. Oh, okay. The answer is 2. I put 2, but we can put the entire thing inside. Oh, because I put, if it's equal to 1, I break. And that's not true though, right? Okay. I thought I could do like an early termination thing, but maybe not. Maybe I can do this. Because the thing is that if I don't do this, I'm worried I'll time out. So maybe it's a premature optimization. I mean, I know that. I mean, that's why I put it in, but I didn't think it through that much for obviously this case reasons. We'll see if it times out without it. 818 out of 823 though. But now we're going to be much slower for cases like, well, the other cases. So it might time out. We might need to do something like this and then still, oh, okay. Actually, that's a little bit unexpected. I was worried about timing more than anything. So okay, let's just say we don't have this for now. I mean, this is basically the same case, but now with, oh no, it's only one modification. With only one, then you have all the numbers. GCD is 2 times, we just take all the numbers, and then the GCD is 2 times the length, right? I feel like we're mostly close, but clearly not. But yeah, I mean, this is gonna not give me anything useful, I don't think. But maybe like oh, I mean, it's just gonna be like too many prints. Oh, it doesn't. Yeah, there. But why is it saying 1500 though? And then start. Oh, I guess it just became best once earlier on. No, I mean, I guess that's fine. Yeah, it should only happen once. And then, but it goes up by 2. It's the product, it's the length times the product, or the GCD. Why is GCD? Oh, because G is 0, because we haven't done it yet. That's why. Because we have, no. Why? Yeah, why? Alright, let's point it out. That's actually, no, yeah. I think my understanding is a little bit off. How many people? Oh, people got it very quickly. I mean, even if they were cheating, it's still. Maybe that is not a still, but 1500. So GCD is. So that's 2. Why is N and start? Oh, there's 2 2's here. So 1 1. Why is it 1? These are all 2's. Why are they 1? Did I mess something up earlier on? Well, I mean, I guess this is the one that. I don't know. Alright, let's see. I feel like I'm debugging something dumb. Okay, output limit exceeded finally, but okay, fine. If best is I don't know. Okay, still output exceeded. Does it actually print stuff at least? Where do you get 9,000 from? Is that? And K is equal to 1, say. Okay, so you have to okay, so that's best GCD. How do I even get 3 as a GD? That doesn't make sense, right? Am I looking at the right cases? Oh, what the? Where did I make this? I don't even know when this happened. G, I probably just like typoed it, but oh, this is GCD of GD and nums of n. I think that's what it used to be. That'd be funny if it works now. I don't remember what I did, honestly. I don't even know what to... no, it's still 1500. Okay, that's good in the sense that like I'm not losing my sanity. But okay, so here the length is to do okay, but it's 1 for some reason. G what is that reason though? Let's go way back. Okay, so the length is 700, but then at a certain point after 750, is this not all? Oh, maybe I misassumed the input. Maybe there's like a 1 in the middle, like 750 in the middle, and as a result you're supposed to double the 1 in the middle. Maybe that's how they try to get you. Maybe I just misunderstood the input. Okay, let's do. Is there? No, maybe. I don't know. Why else would it be at 750 though? Oh, there's a 3 here. Oh, I see. So because there's a 3, they want you to double it. So, oh wow, that's a... How am I handling it? I see. Maybe my... So, okay, so there's a 3. How am I handling it? Goes to then the GCD of what's inside. We only have 1, but we always want to remove the biggest. Oh, but we don't always want to remove the biggest, so that's the assumption that was wrong. Is that we remove... So we have the 200, but then, oh, because you don't want to remove the biggest. In this case, you want to remove this, you want to double the 3 and not double. So okay, so I was wrong in that you always want to remove the biggest number. Okay, greedy doesn't work in this case. But okay, how do we do it then? What does doubling do? Doubling has 2 things. One is doubling the GCD, okay. The other is... Is it a special case or... So then, okay. How do I want to think about this? Basically, okay, doubling means giving a 2 to the GCD. Okay. I mean, and if you double everything, then you have 4 and a 6 instead. You still want to do the 6 to 12 to get the 4, right? So it's not just like an odd even thing. That's a good case. I don't know how I would formulate it. I almost want to like binary search on the answer, kind of, but not really. Okay, let's say we have the answer without all this crazy doubling thing. And then what? And then basically the answer can only be either the best answer or doubled, right? Okay, maybe. I mean, I always submitted twice, so I guess there's a record of this, but so I don't have to copy and paste it to another thing. But okay, so let's say we have. Let's go back to the beginning, right? Let's say we have something like this. Okay. And then now the only way that we improve is just by, is it times 2? Yeah, because if you add in a multiplier, so right, so then here for start, maybe we go again. Let's say nums of start for n in range of start n, right? We go, okay, well, basically, well, first of all, what you want is if GCD of G num sub n, if this is less than best, then let's try it and YOLO. Okay, so used is equal to 0, and then if this is the case, then we just say we used 1, and then G is equal to GCD G num sub n times 2, else G is equal to right? Otherwise, also, and used is less than K. Yeah. Okay, otherwise, if G is less than best, then we just break, because adding more numbers is not going to help. Right, so yeah, I think maybe that's an idea. What do I have? 4. Okay, didn't help for this one though. The answer is, oh, because we want to double both of them. Oh no. Oh, this breaks too early because I forget that because best is not, best has the product. So okay, fine, let's do it this way then. Best is not the GCD, Larry. So how do I best GCD? Maybe, I don't know. How do I greedily use this in a way? We could do it, keep track of the best per length. Yeah, I think we could do best per length, maybe. Keep track of G, right? Okay. And then now we can say best of n minus start plus 1. I don't know that this is any better, to be honest, but okay. And then now say answer is equal to 0, and maybe answer is actually max of best. Oh no, that's not right, because we have to do the length. So okay, so right. Best of L times L, something like that, right? So then now here I'm just like I'm not confident about this at all, to be frank. And let's see what it. So now G times n minus star plus 1, right? Something like that. Oh, outbounds. Yeah, okay, fine. Because it could be exactly n, and there shouldn't be 0 elements, but I guess I'm lazy. Alright, this is still no bueno. I'm still getting the 8 wrong. Why am I getting the 8 wrong? 2, 4. So that means that here it would. Let's print it out. Okay, so. Oh no, not that. Best. Okay, you have 0, 4, 2. So it's gonna be 4 times 2. So for one element, okay, fine. But we want two elements, it's 2. 2 times 2 is 4. But we want, this is wrong on the first calculation. I think that's why. Because we double it, but we don't count it because of the existing G. How do I handle that? Oh, I guess we could just start it like this, actually. Alright, 8 is fine, but then now the 10 is not. What is 10 again? Oh, the 7 times 2, so it's gonna be 14. So okay, so that's fine in a way. Because we definitely do not handle it because of this weird thing. So it goes 14, if G of 7, this is 7, and best of whatever is, how come I don't print best? I don't, oh no, I do print best. One element is going to be 7. So then now we try to use one, we double it. So this should be G is equal to 14, right? Why not? Oh, because it's not less than, it's less than equal to. I guess less than equal to is fine, maybe. I don't know. 8, 14, 15, 3000, 3000. Is 3000 right for the other one? I forget that, honestly. Oh yeah, because you doubled all the numbers. Okay, fine. Am I confident about this? Not at all. Not at all. No idea. Okay, YOLO submit. May even still be too slow. We're so, I mean, we're like 3 inputs out the wrong answer, but still no bueno though. But oh, then I don't know, honestly. I mean, this is way more incorrect, it seems like. I was hoping this greedy would maybe work, but it may be that this greedy is no bueno. But why is that? K is equal to 3, meaning that we just basically doubled all the numbers. Oh wait, yeah. But why do I have this number? What does this mean? Okay, so this is the number from this. Is that right? That doesn't seem right, right? Because that's a way bigger than the expected answer. Oh, I'm dumb. How did this even... Wow. How did this even pass 70 cases, actually? That is astonishing. Okay, but now this is wrong again, which is a little bit sad. But that's fine, right? At least, you know, but this is right. How did that pass 80 cases? I literally just didn't, I mean, I guess here maybe kind of faked it out. But okay, so how do we fix the 2 cases? I do still print best, so one element is going to be 3. And then it's all just 2 until 750 or so, probably. Okay. So then what? That means that now we start at oh, because of this equal sign. Because of this equal sign, because it doesn't improve it when it's equal. But if I don't do it, then I don't get the. How do I try to improve it? Maybe I have to do 2 equations. I think this one here, and then maybe just something like if n minus I would say we want to double all the numbers, but we want to double all the numbers except for 1. Like, what if they're all okay? You have a 4. Is this right? But what I want to say is that okay, so you have this answer. That means that the best answer can only be answer times 2, but I think I also need this to be okay. So maybe I have something like this, and then else if GCD this is so hacky at this point though. Yeah, I mean this is still wrong for this one though. Why? So it goes 2, no double. Basically, we don't want to double anything. This never happens until here. Then we used 1, right? Why is this not right? I'm spending way too much time on this. Okay, so then it's gonna be 2, right? So then now this is gonna be 2. Okay, right. So because we already used it for some reason. I guess that's the answer. Oh, because of this thing, we used it on the first possible thing. Yeah, this thing is not cutting it. Yeah, this is not cutting it as we saw. But then now, I don't know what they not just like tell you what. Okay, because you print too much, they don't tell you anything anymore. Yeah, I just want to see what my outputs are. Okay, so yeah, so this now. For a given length. I don't know. I don't know that I know how to do this one, maybe. How many people got this one? Seems like a lot of people. Very quickly, too. Even if they were cheating. Am I missing something obvious? And it's going to be either the answer. That's not actually true. It's not just answer and answer times 2. Because there could be a slightly suboptimal one in which you optimize away. Right? So then for each L, you can only really go to L times 2. I think. Is that even true? I don't know. A 4 and a 3, and you want to double the 3, right? Okay. But you have a 4 and a 6, or a 2 and a 3. You still want to double the 3. How much time do I have left? Half an hour. I feel like I should skip ahead just because I have no idea. I feel a little bit bad though. Am I close? I mean, this hack doesn't even fix the this case. It's just like very wrong. But that's because I don't handle the case where we use the doubling on all as many numbers as we can to double the answer. How am I thinking it wrong? All right, let's. All right, let me refresh. Maybe skip ahead real quick. We have Q4 maximum good subtree score given an undirected 0 to n minus 1. Each node has and its parent. Okay, so you have a tree, you have a parent, you have values. There's a mod thing, so let's mod it out. Mod. Okay, all right. Subtree of nodes. Every digit from 0 to 9 appear at most once in a decimal representation of the values of the selected node. What does that mean? But okay, fine. The score of a sum of the value of its nodes. Subset of nodes within a subtree is called good. Every digit from 0 to 9 appears at most once in a decimal representation of the values of the selected nodes. Okay. Can it be the values have the values can have 3 and 4. Okay, fine. The score of a good subset is the sum of the values of its nodes. If subset of nodes within a subtree is called good, okay. The score of a good subset is the sum of the values of its node, okay. Define a max score where maximum score sub u represent the maximum value of a good subset, including u itself and all its descendant. It seems like just dp, right? Return all the sum of values in max score. What does that mean? Oh, okay. So you have to get the max score for each one, and then I mean it's just how many trees are there? How many nodes are there? 500. This is just straight up DP then, right? I mean I don't think there's anything too tricky about it per se. Maybe I say that and then maybe I get eaten, but parents survive. All right, so I don't know, right? So for IP in anyway, now E of P that would depend I, right? Okay, so then now we have a tree going downwards. Yeah, okay. So then now we just calculate okay, so the node and then the bit is bit mask, but how do I do the math? How do I do the math? Well, how do I spread it across different trees? I guess that's the question. Oh, this is the same thing as the other problem that we did with the DP over the children kind of thing, right? That's too slow though, isn't it? 1,000 for each one. I don't know. Maybe this isn't quite right. Like I said, maybe I am incorrect. Because then now you want to give. When you have 1,000, so each node will have. Each node doing 1,000 squares, probably not quite the way that you want to do it, right? How you could do a merge that way, but that's not even that much cleaner or that much faster. Man, today I'm not good. Okay. Is this I don't want. I can't prove it. I don't know if it's another one of those problems where a lot of the things are technically not possible, so it's okay kind of weirdness. How do you merge in a easy way? How do you merge in a way that isn't That is in that isn't a million n square. I don't know, but okay, fine. Let's just say we have okay, let's just say we have f for some f, right? For children in the sub node, stuff happens. So okay, so f of children. I guess we'll see. I don't know anymore. I don't know if this is good enough, honestly. I feel like I did a similar problem recently, but always get wonky about this. But okay, let's just use an array, right? No, that copy, does that work? The copy of map, a dictionary. How do no, I guess we don't have to, right? We just kind of so good. So if there's no bit over mass, then dot append. Okay. And then at the end, then we go for oops. Okay, right. Maybe that's fine. I don't know what this loop does. Oh, me running that does. Okay, so we go 0. Okay, so then now just do it for each loop, right? So for I in range to n, score is equal to 0. Score we added by go I. Well, go I returns a map, so then we want max.yu or something like this, right? Something like that should be fine. I know it overflows in some languages, but this is fine. Okay. Yeah, I mean, I didn't do the base case of using this node, right? So using this node, we want maybe we pause it already. For v in okay, right. P dot append get mask of v, and then just v. Doesn't, I guess the I doesn't matter. Just getting the mask, right? So here, what if the number itself has multiple times? Then it just can pick itself then, right? So then, okay, so and also this is wrong, right? Did prevent wrong. But no, I mean, okay, if with the 0 doesn't oh, 0 has to this is so awkward, but okay, fine. I guess this is fine actually. Okay, all right, so then now okay, so it cannot be 0, because if it could be 0, that's a really awkward thing, right? Okay, so if c is equal to x mod 10, if -1, otherwise okay, and then now we do f of, I guess I didn't need to put in a different thing, but anyway, what's it called? Not f, p of node of 0 is the mask, so we just put it this way, and then it's equal to v, which is p of node of 1, something like that. Int, is that not here? Oh. So now we otherwise something like that. Node, what? Int object. Where did I get int object? Did I set it by accident somewhere else? Oh, I said p, so that's why. Okay, fine. I don't know why. I don't even know what P stands for, honestly. Terrible variable names. That's what it stood for. Okay, what is it? 8, 15, 42, 18. The only question is whether it's fast enough, I think. Let's actually cache clear this thing. It doesn't even tell me the time anymore in here. Let's see. Alright, YOLO submit. Whew. Is that an input? That's not an input, right? Okay. So, I mean, if it's in the examples, I would feel way worse because that has happened a lot also. So it's not even like it's, you know. But, okay, so I choose a number that's way too big. The answer should be this, which is, what, this times this. So this is the parent. So it's this, and then this as a linked list. Okay. So here the subtree is just going to be itself. Okay. Let's just print it out real quick. Maybe that's too much. You see? Okay, so then now this 0 case is definitely not right. Because it means that we're not using any numbers. So there's something really wrong here in general. Oh, I'm dumb. This is an OR. Larry. How do I get the annoying thing is that I got the inputs or like the examples right, even given that really silly typo. Okay, so that's good. This one, it actually we're not even that far. Okay, so we got this one, that's good. How much time do I have left? I have 18 minutes left for Q3. Am I thinking about it weird and wrong? Probably. What a silly mistake though. I don't know. There's something to do with twos. Maybe it's the same what idea with the heap. But instead of doing this heap thing, just keep track of inside and outside with the twos of 17 minutes. Okay, I mean, this thing is fine, maybe. We're just doing nothing, right? So, okay, fine. I mean, it's not great, but it's fine. I mean, it doesn't do anything, but it's fine, right? So, okay. And then now, we want to say, okay, so then, I think it's the same idea. Okay, with a heap, right? So you want the GCD outside? Oof. How do let's say we keep track of the number of twos. I guess that's the thing we care about. And then it's just the GCD outside of the twos, which can or right. I don't even know if I would care for this, but okay, fine. I mean, I think we can do something similar to this idea. How would that look like? Okay, maybe I just have something like that. Okay, oops. We could pre-process this. Right? Okay, right. So then now what do we do? So then now we have the same idea. Right? Oops. So basically we want to keep the smallest in there because then we want to double all of them. Right. And by doubling all of them, it just means +1, right? So that means that we have a heap. We want to say, okay. Yeah, and now all the numbers are already processed. So G is going to be, G is equal to D nums start, oh sorry, nums of N, G. We want to say the number of 2's is going to be just limiting by the smallest number, which is the number of things inside the heap, right? Yeah, because everything outside the heap will have, but then you have to do a GCD on that, so you have to be careful. I think that's all, but I think the idea is basically the same, maybe. Yeah. So we want to remove the min element. No, we want to remove the max element because that's fine, right? So then outside the max, okay, so then you have outside is equal to, I don't know, just some big number, it doesn't really matter. Outside the doubling, and then here we want to remove the min. No, we want to remove the max. So then comes sub n, right? And that means that h sub 0, let's just call it inside, is equal to this. So that's the number of 2's on the inside, and you want to double everything on the inside. But before that, let's do the if length of h is greater than k, x is equal to and then outside is equal to min of either x or the outside. So that means that it gets smaller maybe as we pop. Yeah, I mean that's just the number of 2's, right, on the outside. Okay, so this is the number of 2's on the outside of the doubling. Yeah, and then okay, and then inside you go to this, which we always have anyway. And is k always, k is at least 1, okay. So then now f min of inside outside, that's times the power of that, or power of 2 to this, right? Yeah. Actually, maybe I want to write it like this notation to be slightly. Yeah, and outside will dominate, so then you have this. So that times the GCD, or G, times n minus why did I say with start plus 1, and best is equal to f max of this. Someone like this, right? Do I have all my encodes up? Alright, well, that's definitely. Oh, actually, I don't know if that's wrong. I forget what the right answer is anymore. Do these things? Oh, not the new input tells you. That's kind of nice. Okay, definitely very wrong, but I think something like this is maybe right. Okay, so 4 UCD. Oh, it's inside plus 1 because of the doubling. Does that fix it? 8, 14, 15. Oh, wow. Is that it? Alright, I mean, I've YOLO'd on less. If it times out, I'll also be sad though. Like maybe we could have optimized this part. I think that's the part that, I don't know, it's a little bit not so great. But everything else is a heap. Oh, huh. Expected 3000. I guess these are all primes. But I'm returning like a ridiculously big number too. It's not even close. Why is that? 3000 suggests that we can double all the numbers. What is the GCD outside? Why is the GCD so bad? Let's see. Yeah. Let's say if. Yeah, I mean it's fine. It's I don't even know what the. We have 8 minutes left, so I might not make it. Num sub 1. What? Oh, I meant this one. But okay, start N and G. Okay, it should be all ones. So where does it get the? Inside outside? Am I doing something wrong? The inside outside? Inside should be all. Well, the smallest. Damn. No. Oh, I'm dumb. I'm removing the biggest, but this is not the smallest that's inside. The smallest number is the choking point. So okay. We okay. I don't know how that didn't catch more cases. Again, 819. What do they have 800 test cases for? But okay, fine. What is the smallest number that's inside? I guess the smallest number will never get changed, so we can maybe do smallest inside is equal to whatever, right? And then now I guess just call it inside really. And then inside is not equal to this, it is equal to the thing that we just put in, which is 2 sub n. I guess we don't need to print this because this thing is kind of running a little bit slow as a result. Okay, so this everything else still looks good. I don't know how that passed so many test cases, but I think this is the one that I don't remember. The other. Okay, so let's YOLO submit. Hopefully not too slow. We have 6 minutes and 30 seconds left on the contest. So if it's too slow, it'll be very sad. I think this is the only thing I should be able to optimize. Probably could have done it honestly, but I guess I could write this to begin with. Yep. 822 over 823. We'll put it in here. Let's run it real quick. We have 6 minutes. I think we should be able to get this, unless Leetcode is just being unreasonably silly. This takes 1.3 seconds. Let's see what happens when we do that. Let's see, it was 1, right? So fly in range of, what did the numbers go up to? 109, so just whatever, 35. p dot append was 1 times 2, and we should be able to go what the p of this. Is that faster? Oh no, it's slower actually. I mean, this is actually what I worried about, the n square log n. Can I do a little bit faster? 5 minutes. I don't know if I can get it right in time. We moved the max. The max doesn't matter because the max is outside, so we can remove this. Because by definition, the max is going to be whatever, and then inside plus 1. No, this isn't right though. I mean, it may be faster, but I think I'm off by a little bit. I think the thing is that we have to check that. Oh yeah, outside. So then here it's kind of right, but because outside has to be. Was it that much faster? No, not really. Okay, so we kind of need this, but. So can we get rid of the heap? I have 4 minutes to get rid of the heap. Because we have to count the number of things. So another way to do it is just by having a frequency of the smallest number, right? Okay, fine. I don't know that I have time enough for this, right? So it's not a heap. We go f of 2 sub n increment by 1, right? So then now we go, okay, what's on outside, right? Well, inside is just the smallest number, so that's this, that's fine, right? And then, but then now this is, okay, can we double all the smallest number? So if f of inside, or f of inside is less than or equal to k, then we can do inside plus 1 because that means that we can double all of them. Otherwise, then we do just inside. Yeah, because that's the smallest number, right? And then now we got rid of the heap. Got rid of the heap, but it's still not as fast as I would like, honestly. Is the answer right though? I think the answer's right. I forget what. Oh, they don't tell you. That's why. I was like, I don't remember this. I'm gonna YOLO submit because I have 2 minutes and 30 seconds and no other reason. I don't have time. But we got rid of the heap, so it should be faster. We don't need the outside anymore. F. We don't even need that. We can maybe replace this with a count, right? So F. Okay, we got it. Okay. Whew. With 2 minutes and 11 seconds to go. That's tight. Whew, okay. I will do a micro optimization because yeah, F should be the count. So then now, yeah, if no, F is already inside. So then now min. Okay, so here, if F is so inside the number of numbers within the smallest, right? I think this is wrong. I think I did this a little bit wrong because this doesn't make sense to me. But so maybe this is wrong anyway. But because now that I'm doing the optimization, because you want the min of. No. Okay, no. The inside is right. So then now we want if if inside is less than 2 sub n, then f is equal to is equal to 1 for this exact number. Otherwise, else if inside is equal to 2 sub n, then f increment by 1, else then it just doesn't matter, right? So then here now inside is equal to 2 sub n, something like that. And then now this is just an f statement. We have 25 seconds left. Okay, maybe we won't get to it. Inside, if is it the other way? It's min. If 7 seconds. Give a segment. I don't know if this is even right, but I mean, it's an optimization. We already got it, right? It's just I'm curious. Now the contest is over. I don't know why they kind of get rid of it, but yeah. I don't know what the timing is though. They tell you? They don't tell you because the contest is over. Thanks, Leetcode. You are so dumb. Let's see. But yeah, I mean, I don't know. Why did I get so much spam? Yeah, so just changing that from the frequency table to using a counter. You know, this is twice as fast. Even though they're both AC, this is clearly twice as fast. So yeah. All right. Yeah. I mean, I don't like to end it without my screen. I mean, you know. Let me put that here. Yeah, that is all I have for this one. I think I guess I'll do a quick post-mortem actually. I've been kind of trying to do a little bit of that, or retro, I guess. Post-mortem sounds like I killed someone, but there's one more thing that I wanted to do, but I forgot what it was. I don't know. That's it. Oh, whatever. Let's just do the post-mortem or the retro real quickly. Yeah. Q1, pretty straightforward once you understand what it's asking. 3 minutes for me was actually a little bit slow because I just wasn't sure. But then here it just means that I think the way to think about it is the inverse of this, which is for every number you can only choose it once. So then you just take the best 3 out of those. That's fine. This is a standard DP problem. I was slow because I was typing it a little bit slow. I think this is pretty straightforward, understanding wise for me. You know, we'll watch the video for explanations if you care about that. Maximum subarray GCD sum. I mean, this is the one that obviously I struggle with a lot. I think I didn't appreciate the doubling part enough to kind of factor out the ends and the ends GCDs. Maybe that could have been earlier. And then this one I thought was, I want to say straightforward, but the hard part is just proving bounds. And a lot of it is just like it's self-pruning. A lot of the things are not possible. But the other thing that is why I was able to come up with this relatively quickly. I don't know what time I took because a lot of the time was spent on Q3 and not Q4 on this clock. But a lot of this is because it was on like a similar idea was done like a week or 2 ago, right? So that's why I was, you know, able to implement this very quickly. I mean, I think the idea I still would have came up quickly, but I think there's some implementation things that, like I wasn't sure. Oh, last week or 2 weeks ago, or whatever it was, I wasn't quite sure. But this week I was able, you know. And honestly, it is a little bit YOLO because it is self-pruning, so the proofs are kind of a little bit awkward. So I don't know, a weird contest for sure. I don't know what to make of it. But yeah, that's it though. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.